Okay, this is question 5 from 2005 MMPC. You know it's from the 2005 MMPC round 2 because whenever you see these seemingly arbitrary large exponents or numbers like that, yeah, 2005, right? So a is a complex number such that a to the 10th plus a to the 5th plus 1 equals 0, and we've got to find the value of this, a to the 2005 plus 1 divided by a to the 2005. So this is actually a kind of typical sort of question, and I think it even showed up in a similar form on the most recent Math Madness. So not bad for a question number 5 on the MMPC, but it relies on, the easiest way to solve it relies on seeing some kind of tricky thing to do with the algebraic equation. So we start with this guy, and like you might be tempted to solve for a because it's in quadratic form, and so you can use quadratic formula to find a to the 5th as a complex number, right? But then, yeah, do we have to take a 5th root of that answer? I hope not. Maybe we don't have to anyway, because at least these are perfect powers of 5, but still I've got to take, even if I knew a to the 5, I'd have to raise that thing to some large power. So, okay, the trick is take this equation, multiply it by a to the 5th. So if you do that, you get a to the 15 plus a to the 10 plus a to the 5 equals 0, but now we realize that a to the 10 plus a to the 5 is negative 1, so this tells me a to the 15 equals 1. And now that I know this fact, it should be pretty easy to figure out these guys. So the idea is a to the 2005, well, that's close to just a power of a to the 15, right? Like, we want to find a multiple of 15 that's close to 2005. So 2010 is a multiple of 15 that's close to 2005. So this is a to the 2010 divided by a to the 5. And so by the same token, this guy is a to the 5 divided by a to the 2010. Right, so the idea is that 2010 is, oh gosh, I don't want to do the division, but, do I have to do division? No, 1, 1. Let's see, 2010, 1, 51, 3, 60. Okay, so if I got this number wrong, it doesn't matter. 2010 is a multiple of 15, so whatever number you need to do, like, this is just 1, this is just 1. So from here, what I want to do is realize that, so this is 1 over a to the 5 plus a to the 5, okay, equals the value we're looking for, call it x. What I want to do is multiply this equation by a to the 5 again. So I have 1 plus a to the 10 equals x a to the 5. But what is 1 plus a to the 10 is minus a to the 5. So minus a to the 5 equals x times a to the 5. So x equals negative 1. So that's one way to do this problem purely algebraically. The reason I wanted to talk about this problem is, what if you didn't see this trick? Could you still do it by solving for a to the 5 first? You could, and I'll show you how to do it just because I think it's useful if you guys have seen a complex form of a complex number, polar form of a complex number. All right, so starting with this equation, if we use quadratic formula, we get a to the 5th is minus 1 plus or minus square root of 1 minus 4, so negative 3 over 2. So this is minus 1/2 plus or minus root 3 over 2i. Okay, so when you see this kind of number, negative 1/2 plus or minus root 3 over 2i, we think about where this is in the complex plane. And where it is, it's right on the unit circle. At an angle of either pi over 3 or minus pi over 3 in a standard position angle. So the way to write a complex number in polar form is, well, if you're on the unit circle, this point is e to the I theta. In this case, theta is pi over 3. So if you've never seen this before, it's really worthwhile to take some time, look it up. I don't mean plus or minus, I mean the whole I is multiplied by the whole I times the angle is either positive or negative. It's really useful to look this up because if you can write down the polar form of a complex number, then raising that complex number to any kind of exponent becomes really easy. So if you know this, then a to the 2005 is a to the 5 raised to the 401. And that's going to exactly be e to the plus or minus I times 401 pi over 3. And then a to the minus 2005 is just e to the minus or plus I times 401 pi over 3. And so even though we don't know the value of a to the 5 from this equation, there's two possibilities for a to the 5th power. But for either one of those, when I add these two guys together, I'll get the same value. So my answer should be e to the I times 401 pi over 3 plus e to the I times negative 401 pi over 3. Okay, and now, again, this is not as easy as the algebraic trick way, but we can proceed here. What is e to the 401 pi over 3? Well, that's my angle is 401/3 pi radians. How many circles is that? Well, if you think about it, 402 pi over 3 is just a certain full number of rotations. So this is 1/3 of a pi less than a full integer number of rotations. So therefore, this first term is the same as e to the minus I pi over 3. And this second term, my rotations are going clockwise in this case, and I'm 1/3 of a pi from a complete number, integer number of rotations. So the terminal point of this angle is the same as pi over 3. So it's e to the I pi over 3. So in other words, the sum of these two values is the same as the sum of these two complex numbers. And since these two complex numbers, I've already written them down right here, add them both together, the imaginary part cancels out, and you just get minus a half minus another half equals negative 1. Okay, so again, that's not the best way to solve this problem if you're going for time, but I think it is useful to learn about polar form of complex numbers and how you can do this kind of math. Some other polynomial type questions can be approached this way when they don't have quite as easy of an algebraic trick.